etc. is what we have seen yesterday. Okay, today we'll start looking at dashboard design service, guys. Okay, so before that, we just start looking at what is these dashboard servers are and what is actually a dashboard, how it works in business object context, what are the core areas for it. Business object dashboard design is formerly known as Excelsius, guys. It is formerly known as Excelsius. It's a piece of software allows you to develop Flash-based dashboards. Okay, as we talk about a dashboard is actually a collection of information extracted from varieties of different sources, eventually aligning all of this information into a single piece of area. Simply to talk about, to give you some brief introduction about a dashboard, is we use it every day, and we typically use it in your car's dashboard, the one that's sitting next to your steering, or eventually your bike. When you ride a bike, you have a dashboard. It has a speedometer, it has a fuel capacity area, it has a couple of other tachometers, etc. It's like nothing but it's a simple dashboard. Is going to illustrate us various things for us. All of this collaboratively plus into a small place which can give you the consolidated information with a glance. Similarly, BOE has a platform previously first known as Excelsius design, guys, Excelsius. And eventually with the version 4.0 onwards, the same Excelsius is now rebranded and known as dashboards. It's called BOE, Business Object Enterprise Dashboard. It's a tool for data visualization, the creation of dynamic and interactive dashboards. You can be able to visualize the data from different forms consolidated together. You can visualize this data using different kind of charting mechanics, a bar chart, a pie chart, a column chart, even based on a map, speedometers, traffic light signals, etc. You can do a variety of visualizations. It also has interactivity. By selecting a specific value, you can filter out the data and visualize the data by interactivity. Data and formulae are imported or directly entered into an embedded Excel spreadsheet. Each of the enterprise dashboard will be associated with a Microsoft Excel spreadsheet attached with it. A dashboard, actually, previously the word called Excelsius is actually equals to excellency built on Excel. Microsoft Excel is the source of data, guys. It contains all the data which you extract from different sources, which is typically been put into Microsoft Excel platform. So you build a layer on top of data residing in Microsoft Excel for your presentation. The Excelsius is actually abbreviated into excellency built on top of Microsoft Excel. Yeah? So eventually, guys, the whole idea is, that's the reason when you start an Excel dashboard, it will be attached with an embedded Excel spreadsheet. This embedded Excel spreadsheet is further modeled to pick up the data from different data sources, amalgamate it into the system, and eventually start building a presentation layer on top of the data. It's a Flash interface provides a canvas that can display a variety of analytics and dashboards, such as speedometers, traffic light signals, a variety of charts, speeding controls, etc. All these things that can be amalgamated, presented on a canvas, which is a Flash-based environment. As we know, Flash is an interactive component, isn't it? Microsoft Adobe Flash is basically an interactive component. You can play sounds, you can even showcase the visualizations in an interactivity. It's interactive, it's been built. Data can be updated dynamically from Business Objects BI platform and exported to a variety of different formats that can be used by the consumers in standard formats, such as they can export the specialty dashboard created into a PowerPoint, a PDF document, to a Microsoft Word document, or even to a Flash embedded file. It creates a Flash file. The Flash file you can embed into a web page. Once it creates, it basically amalgamates the data, creates a visualization into brings you a shockwave file. The shockwave file can be presented even to an web page using an embed object. Yeah. In order for you to manage and maintain these dashboards, it also has specific services which are designed and catered to perform these activities. There is a server called Design Cache Server, Dashboard Design Cache Server. It intercepts the report requests sent from clients to the Dashboard Design Processing Server. If the cache server cannot fulfill the request with the cache report page, it passes the request onto the Dashboard Design Processing Server, which runs the report and returns the results. The cache server then caches the report page for potential future use. Basically, it is similar to the cache service that we have seen in the past, such as Crystal Report Cache Server, Web Intelligence Cache Server that we have talked about. Similarly, we have a Dashboard Design Cache Server. If a requested page, if the end user wants to view the dashboard, if it has already created a page, it already exists, then it will actually showcase or pick up an existing instance from the cache server, present it to the end user. If there is one does not exist, eventually it start looking at the Dashboard Design Processing Server. The whole idea for this service is to pick up the request, perform the activity, and generate the page, send it across to the end user. While doing so, it also talks to the Dashboard Design Cache Server, will preserve a copy of it. Responds to dashboard design requests and shares data between reports to reduce the number of database accesses. If first time there is no copy exists, Dashboard Design Processing Server will come in picture, execute this required reporting content, creates a page, keeps a copy with the cache server, another copy, the same instance will be presented to the end user. The process flow here, guys. Dashboards can be accessed again from the BI Launchpad, or it can even be accessed from a variety of other sources. Typically from BI Launchpad, let's see this. If you are using a universe in a SAP Business Object Dashboard, dashboards, web server, web application server, CMS, authorization management, that all comes in picture. Okay. Eventually it goes down and picks up an instance of it from the input FRS. Eventually, based on the need, again, it will again present it back to the web application server, web server, and user. Basically, this is a typical process. If you have already a cached copy. We have not seen the cached server here, but it's an internal process. Clear so far? Managing the dashboard servers. PO dashboard design sends a core bar message. A core bar is like I said, it's a DCOM component which is built on top of a Java technology, which is the core component of your BOE system, which is used to communicate between the services. Message to the CMS for the user to log into the BOE platform. The CMS checks the CMS system database to authenticate the user and checks the rights. CMS returns information about logon success and user rights to the BOE dashboard design server. Dashboard design sends HTTP request to obtain information about the universes. If it's been built on top of a universe, default universe, which can be supported for the dashboard design server from version 4.0 onwards is .unx, or dashboard design server. A dashboard can pick up the data only from the universes which have been created on top of IDT based universes. Universes that are designed using information design tool. They will have an extension called .unx. UNX available to the user through the web server, to the web application server where the Excelsior web service is running. What happens in the background is that this dashboard thing is basically, you want to pick up a data. Let us say you want to pick up this data, guys. There's a sales information such as state, city, store, volume. This is what you want to extract. 1, 2, 3, 4 columns. Based on these 4 columns, you create a query. This query will be generated or created as a web service call. As we discussed web services, remember? On the day 1, I believe. Web services are basically on-demand report requests. Information provided or facilitated on demand whenever you request it. This query will be converted into a web service. This web service is of dashboard report services, Excelsius-based web service. This web service query will, whenever you make a call to it, it will respond with the data. It might have an input parameters such as where classes, etc., which will translate them and sends the data back to you, or vice versa is a possibility. So basically, each of the query that you constructed will be transformed into a web service, and the web service call is generated in the background. Corresponding to the web service call generated, a request is being processed and a response is generated. Okay, so basically it will makes an HTTP request to the web service. Excelsius Web Services sends request to the CMS to obtain information about the universes available to the user. And the CMS checks the CMS system database to determine which universes are available to the user and where the universe files are stored. Basically, the whole idea for this is to tell you that the moment a request has been raised by the web service will communicate back to the CMS. It will ask you, hey, this is the corresponding universe, where it is located at first. Yeah, it will give you the information. It also tells you whether or not this particular user who logs in and makes a request has authenticated to use that particular universe. Not only the dashboard, user must also have an authentication and security rule applied on top of the underlying universe. Only then this request gets fulfilled. Otherwise, it will be thrown with an appropriate message by the CMS that this user is not authorized to access this particular environment. Yeah? CMS server, CMS obtains required resources and such as universe files from the input repository. So input FRS is where, as we talked about, all the universes are going to be stored in the input FRS. CMS sends the information about the universe available to the user to Excelsius Web Services. It will tell you, goes on, picks up this information about this universes from the input FRS. While doing so, it also cross-verifies its user authentication, sends its request and sends it back to the end user. Tells the Excelsius Web Service, yeah, this is the location of the universe, these are the rights that are obtained for the universe. Excelsius Web Services sends the information about the universes available to the user through the web server to the Business Object Dashboard Design Server. Once this authentication process has been completed, a corresponding user validation has been completed, this information will be sent back to the web service, Excelsius-based web services, and which will internally send from the data, it will send back to the web service in the background. The user selected universe and builds a query based on that universe in the BOE dashboard design query panel. This is the design time panel. And the user binds the query to a visualization. This is a whole life cycle of creating a dashboard. Meaning, you go open a dashboard design, you establish a connection to one of the existing universe that internally creates a web service. The web service will again check back the authentication of the user, whether or not he is authorized to use this. Then once it has been subsequently done, it can be able to produce the information for you. That produced information you're going to embed into the Excel spreadsheet. From that Excel spreadsheet, you will map them into a dashboard design controls. Okay? A dashboard can include multiple visualizations, and each visualization can be bound to a different query. It is not one, but you can pick up the data from a variety of different sources. Maybe a different kind of universes, or different kind of data sources. It can even be, it may contain some static text too. All of this can be mapped into visualization controls. Clear? The whole idea, guys, BI Launchpad. From here, a request has been sent from here into Web application server, CMS identifies, sends it back here. Correspondingly, let's look for the dashboard design cache server for availability of a report. If one exists, it runs the request to the web application server to present the data. If it does not exist, then it will start telling that this does not exist, and eventually it communicates back to the dashboard processing server. Okay, it is not mentioned here, but it will actually goes down to the dashboard processing server to process the request by picking up the design of this from the input FRS server. Eventually creates a page. The created page, a copy of it will be stored here. Other copy will be presented back to the end user. An instance previously exists, dashboard design cache server comes in picture. If it does not exist, it also brings in the dashboard design processing server along with the dashboard design cache server. Because one instance creates, sends it back to the end user, and eventually created instance will also be preserves a copy in the dashboard design cache server. Clear on the process flow? Process flow clear, guys? Cache server. When it comes in picture, let's talk in bit detail. Okay, the user sends a view request from the BI Launchpad to web client to the web application server, where BI Launchpad web application server is running. Web application server recognizes the request as a request to view the dashboard of a dashboard design object. Web application server communicates with the CMS to obtain the dashboard shockwave file. Each of the dashboard once created will be presented in a SWF file. Okay, and the language corresponding to the user's preferred viewing locale. A locale setting, as we talk about, as a multilingual data can be facilitated. CMS checks the CMS system database for the dashboard shockwave file. Its corresponding link. CMS obtains the dashboard SWF file from the input FRS. CMS provides the dashboard SWF file to the web application server. And when user, web application server sends the dashboard file to the web server to the web client, where the SWF is rendered or presented. SWF sends a request through the web server to Excelsior Web Services. Same input FRS. Web service. Okay, there is a location called, I will show that to you later on. There is a location called dashboard DSWJ. There is a file location. No, this is an internal communication is being done. That is, this is basically a web service creation is an internal communication. It is not, it is transparent to the end user. In this process flow, a web service request is created when the moment you reference an input FRS file for a dashboard, for an existing universe connection. Okay, it's basically it's an internal system communication being done. Did you get that? It is again a web service that is going to be hosted in a location called DWS BOBJ something. I can show that to you going forward. That's the location where actual web service is being, all the web services that are created will be stored. From here, it first picks up, looks for the cache server. Cache server, if one exists, it's fine. The request gets end there. If it does not exist, it picks up from the input FRS, it picks up the universe design. Universe design, and eventually it communicates, again, it also picks up the copy of the SWF, translates it. There is eventually it finds an Excelsior web service associated with the shockwave file. The web service will then be called based on the universe. Universe is designed to facilitate a query. That each of the query will be translated into a web service. Web service. Okay? Because a web service whole concept is that it is transparent to the end user. End of the day, like it doesn't know where is the origination of the source data. What is the source of the data? Users will not know. Users will only know what data is presented to them. Output. So similarly, in this case, universe is used to create a web service based on. Then, whatever is the web service that is constructed on top of it, that would then be presented to the end user. Basically, the communication between web service and dashboard will come in picture here. This is a transparent to the end user here. Okay? Okay, so web service running on the web. End of the day, the request will then be translated into an XLSS-based web service, which then communicates back to the underlying universe, picks up the data, presented to the end user and all that. Dashboard may require one or more query results depending on the visualization, as we talked about. And may contain one query, multiple queries. It also may contain different varieties of sources using which you can pick up this data sets. Web service sends a request to the dashboard design cache server requesting the universe query result set. And the dashboard design cache server checks with the CMS to see if the user has rights to run a query of the universe. If you notice these two steps, you will understand its core relationship. A query which gets translated to a web service internally calls the underlying universe. Okay, this particular universe end user who is running this particular query should have authorization to extract the data on this. If we talk about a dashboard also requires to have a connection to, it can be into different data source, and that create a different data source must be authorized by the end user. Right? CMS checks the CMS system database and returns the information to the user on the rights. And the dashboard design cache server checks to see if the query results already exist in its cache. In this case, a result does not exist, does exist. The dashboard design cache server returns the result to the XLSS web service. If the requested query is the same, corresponding data set is already exists, it will not look for the new data. It will look up, if it is basically a viewing request, go down, and if there is already an existing instance exists, pick that instance, present it to the end user. If there is one does not exist, it will start performing a new request altogether. Clear? Yeah, it's basically, take a look at this. It talks a bit more. This is the additional to the dashboard design processing server will comes in picture. Dashboard, web server, web application server goes down to the dashboard design cache server. Check for an instance of it. If there is one exists, present it to the end user. Does not, again, eventually it checks for the authorization of the user, communicating to the CMS. One exists, request will send back to the author. Okay, XLSS web service comes in this area. Because FRS, this place contains a UNX. Translation will be done of the query that in there. Clear? This design cache server is responsible to look for an existing instance. If it is found, returns it to it. Does not found, then the translation of the query will done. Eventually that query from here sends back to the dashboard design server. This is where the query translates and which picks up the data from the underlying relational database systems. Present it to the end user. Previous one does not have a dashboard design processing server inside. Yes, but which internally checks for the CMS for authorization. Yeah, it will. Right. It will check. It first goes to here, then it will look for an CMS authorization. If the CMS is authorized, then the flow comes to the dashboard design process. Slightly different than the web intelligence application server, where the CMS comes first. First, CMS. Slightly. The whole idea is like this request receives into it. Basically this comes here first. From here again it picks up this information. Okay, this is the thing that the user wants to see. This information is requested. Then it communicates back to the CMS. Because the whole idea is that once it creates a shockwave file, because it's a shockwave file, it's a generic object. It may not have complete authentication on it because it's not a SAP BOE a native application platform. Maybe that's the reason why. This is my wild guess. I'm not quite sure. It's basically the whole idea for this is basically to come down here. It looks for the cache information. Okay, there is one exists here. Can I present it to you, him or not? That will be authenticated from the CMS. With the response of CMS, it communicates back to the end user. Or alternatively, otherwise, it looks for the dashboard design process. Slightly different. Processing server, design processing server. It sends, the whole idea for this is to send an HTTP request through the web server to Excelsior web service. Okay, which is typically internally retrieves a universe to produce the query. Okay, the dashboard may require one or more query results as is standard for us, as we know. It may be facilitated from more than one user. This process assumes the user previously logged into the SAP BOE platform and a dashboard designed to access the universe. The whole idea is that this cycle will only come in picture if the dashboard is been built on top of an existingly created universe. This gets appropriately if this is because a dashboard can acquire the data in different forms. Universe is one form. You can also acquire the data from another query tool called Query as Web Service, QAWS. You can pick up the data from another product of BO called LiveOffice. It can also acquire the data from an external web service which is hosted on the internet. Okay, let us say you can also create a dashboard to showcase the stock tickers, which has been hosted by some other external website. It can be by Reuters or Bloomberg or whatever it is. You can even pick up the data from news, let's say Google News. You want to showcase the randomizing of this news. It's from external web service. You can even pick up the data from SAP BW system. Pick up the data from XML file. You can actually host entire data in a static text within Excel spreadsheet. There are about 11 to 12, I think 12 different types of sources that it can extract the data from. Dashboard data can be acquired in 12 different types. This whole process cycle will come in picture when this dashboard has been built on top of IDT based UNX universes. Yes, there is a translation that does happen. Convert in the sense like what happens is that end of the day everything it receives as a web service. Output will be like always is dynamic. Since it is a web service, output is always dynamic. The content it gets changed automatically. As long as you build anything on top of here, which is actually a web service in the background. Even if you acquire the data, no, the moment you talk about dashboard, okay, the moment you acquiring of a data into dashboard, typically goes on top of a web service. This is specifically to the dashboard. See, the dashboard is a combination of many things. Many things. Maybe an organization may contain information stored in different kind of forms. Let us say you're building a dashboard. Okay, you're building a dashboard to a CEO. CEO is someone who is head of the entire business basically. It's a publicly listed firm. Its corresponding stocks have been listed in different exchanges worldwide. The moment he wants to see the entire business information in a simpler dashboard, A business may contain different varieties of streams of business segments. Yeah. Universe. Yes. Yes. For if it is something else, if it is not this, if it is not based on UNX, even then it is considered as a web service. That case, you will not see the UNX connection here. But the actual web service which has been acquired, let's say you can even acquire a third-party web service which is hosted on the internet. Let us say stock tickers. Okay, most of the websites today which are related to stock exchanges can give you a free web service which will process the stock ticker and corresponding rate of a stock. So that information can also be assumed. In such a case, the web service communicates with that web service. If you notice this, yeah, let me answer this question back here. The CMS, we have talked about why this specific scenario, it does the authentication later on, not before. This authentication thing comes in picture at first at the object level. Object level is like, end of the day, the user can access it or not. That's one fundamental thing. Second thing talks about it, internally if this particular dashboard has been built on top of a UNX universe, then CMS checks back this particular universe is authenticated to the end user or not. It might even be the case this particular dashboard has been completely built on external data sources. It is no way connected to the business objects data. Then CMS object conditions does not apply. It looks at the authentication at the CMS particular created shockwave file itself, which is the end product. Like I stated, you can pick up the data from about 12 different sources. 12 different data sources of information. Using 12 different types of connections, you can acquire the data into dashboard.
But there is a web service communication problem is going. How do you identify?
It throws the corresponding error to the end user.
Throws corresponding error.
If it is an issue with the connection, because web service is an on-demand. The whole idea is whenever you pick up the data, you put a request from the web service, the dashboard here, internally calls a web service. The web service internally calls the relational database underlying in it. You would have to troubleshoot the source, which is the universe. Universe. That means the cache server might be down. The thing is that a web service is hosted. If the web server is down, then the web service will be down. If the web service is down, you cannot even log into the CMS system. Web services are hosted on top of a web server, which is going to be the same in this case, where you log into the BOE platform. If the web service is down, which internally tells you that the web server itself is down. That is a typical possibility. There is a service that exists in here called RESTful Web Service. There is a service called RESTful Web Service, which is part of your BOE platform. This web service is actually the whole responsibility of this RESTful Web Service is to manage this web services component for you. It is an application. You can see it as an application in the CMC. Clear? But generally, if there is a communication problem that happens to the underlying database systems, it will throw the appropriate error to the end user. So far good? Okay, dashboard design cache service checks with the CMS to see if the user has rights to pick up the data of the universe. CMS checks the CMS system database communication and comes back with the appropriate information. If he is authorized to use it, it will give that information and eventually the query being executed. Dashboard design cache server checks to see the query result is said already exists in the cache. If it exists, present the existing copy. If not, it will eventually process this data using the processing server, dashboard design processing server. It gets a copy will be cached, the new copy will be cached into the cache server, also presented to the end user. Clear? Second, output file repository. Once a value gets created, a copy of this, a schedule. Once you schedule this dashboard to refresh on a periodical basis, it creates a copy of it in the output FRS. If it is output FRS, if the copy exists in output FRS, it exists in the cache server too. Yeah, it's a standard. It's a common rule for all the objects within the BOE platform. If the query result is not in the cache, this is the typical life cycle that goes on. This is similar to the process flow we have seen a while ago in the other slide as well. It's just the same thing, guys. Metrics is a bit more important for us to take a look. The number of open jobs, it shows you the table listing the jobs that are currently being done on the server. Includes the ID and name of the document, the name of the user running the job, the date that the document was last accessed, and the amount of time that the job has been running. Number of requests served, total number of requests that the server has served since it started. Number of open jobs, number of currently open jobs that the server and its child processes are currently processing. Object time, the average time in milliseconds the server has spent processing the last 500 requests the server has received. If this number is consistently high and growing, we need to consider creating additional service to the other machines. This is like apparently only difference here is that this particular thing comes in picture and this particular thing comes in picture only at this 500 reports. Yeah. Average processing time, it's in milliseconds. The maximum time in milliseconds that the server has spent processing one of the last 500 requests. If this number is consistently high and growing, consider creating additional service on the machine. Maximum processing time, it's again millisecond, the amount of maximum time it has taken to while processing this. Maximum amount of time it has taken to while processing a document. This is again coming from the last 500 requests. Minimum processing time tells you the minimum time it has taken, vice versa of the maximum time. This is also based on the last 500 requests. Number of queued requests, requests that are either waiting to be processed or being processed. If this number is consistently high again and growing, consider creating additional service on the other machines. Object DLL name, the name of the processing plugin for the server, the value of this metric does not change. It's a standard. It's basically the DLL information that has been presented to you guys. Similarly, you have request failure rate. What is the rate of failure of requests? How many requests that it has received and how many of them are failed? Max child processes, maximum number of concurrent child processes that are allowed on the server. One master process and corresponding child process. One master process will process the document and additional child processes will be used to source the data from different sources which are part of it. Because a dashboard may contain different, like we discussed, different variety of sources of data. Cache hit rate, how often you hit the cache, and the percentage of requests over the last 500 requests that have been served with the cache data. Connected processing service, a table listing the dashboard design processing service in your deployment. It also lists the name of the server and the number of connections that are currently open with the server. Number of requests served, the total number of requests served since it started. Object type, info object the server primarily deals with, the value of this metric is again static. Average processing time in metrics. This is again, if you notice this, it looks pretty similar to the dashboard processing server that you have seen. Primarily, most of these metrics are generically pretty looks one next to each other. Maximum processing time, minimum processing time. This is again the same for the last 500 requests that it has taken to serve this. And object DLL name, it is a standard DLL name that is being utilized for. Cache size, the amount of data in kilobytes that is currently being cached by the server on the disk. Number of open connections, number of connections that are open. Data transferred kilobyte, the total amount of data in KB that have been transferred to the clients since the server was started. Because cache server is all about like caching the data, which actually stores, it also needs a specific space, requires a space to cache this information. This gives you how much amount of data that it is actually transferred from its cache to the end users or the user requests that have been created. Clear? That's about the dashboard design and processing service. Any questions here? Clear? Folks on the phone, any questions, guys? We have just about 2 guys today. Let's look at the connection servers. I will also walk you through these metrics subsequently with the connection server later on. Connection server provides database access to the source data, typically to source data. It supports relational databases as well as OLAP and other formats. Connection server is responsible for handling connection and interaction with various data sources and providing a common feature set to the clients. You have 2 types of services here. A native connectivity service, which is the nature of the service, which is also known as connection server. It provides native connectivity to 64-bit architecture machines. Similarly, you have native connectivity service 32-bit, which is typically been used by connectivity service or connection server 32, which provides native connectivity service to 32-bit architectures. One for 64-bit, other one is for 32-bit. Previously, in the previous versions, let's say 3.1, you don't have these 2 segmentation. You will have 1 connection server. With the 4.0, you have 2 services here. Okay, this whole idea is to explain the process related to the connection server in this context. Okay, let me talk about the slide which explains what we have done in the background. Let us say a request has been done by the end user to view or run a report. Let us say typically once you schedule a document, how it happens. A CMS looks for the authentication. It is standard because scheduling is always been done on the CMS system, which is standard for us. Then after, a scheduled document will then be processed by adaptive job server, which internally calls, if it is a web intelligence document, it calls for the web intelligence processing server. Web intelligence process server will again require to pick up the connection information, the corresponding universe information. universe is being hosted into the input FRS. Input FRS, which is being used to pick up this information from the input FRS. It picks up the information from input FRS, and picked up input FRS information, which contains a universe and corresponding connection information. Based on the credentials that are supplied in the connection information there, if it is a 32-bit operating system, the connection server 32 will come in picture, which communicates back to the RDBMS systems. If it is a native 64-bit compliant connection that is being used with the input of the underlying connection, then the connection server will utilize the 64-bit native connectivity service to connect back to the relational database system, which internally produces the data. The produced data will then be sent back to the web intelligence processing server, which renders this information and creates an EPF page. The created EPF page will be stored into the output FRS. Also, the same thing will then be moved into the adaptive job server, which is based on the type of format that is in context, okay, and presented, and eventually it notifies the CMS system that this job has been done, completed successfully. CMS comes back and updates its CMS system database of the scheduled job status has been completed. If you notice, this entire life cycle is the same. Connection server 32 or 64-bit will come in picture the moment you try to connect to a different kind of, it can be the moment you're trying to connect to an OLAP data store or a relational database management system based on a universe. It picks up its metadata information by going into the input FRS, and input FRS contains the structure of your universe, picks up that metadata, eventually connects back to the underlying RDBMS, picks up the data. Picked up data will then be routed to the web intelligence processing server, which internally sends it back to the output FRS by creating a page, which is an EPF page. The created EPF page then sent back to the end user. Clear, guys? Okay, so viewing, what happens, what is the role of a connection server when you are viewing a document on demand? That is actually a scheduled document, which has an adaptive job server coming in picture and performing this. What happens here? The user sends the view request from the BI Launchpad, the client to the web server, to the web application server, and then again the CMS will come in picture. And eventually CMS checks the authentication. CMS sends a response to the web application server, confirms it that the user has sufficient rights to view the document. Web application server sends request to the web intelligence processing server. Web intelligence processing server will come in picture because it's not a scheduled document, it's a processing need. It's directly the web intelligence processing server will come in picture and requesting the document, which again connects back to the FRS, input FRS to locate the universe, pick up its metadata and its connection information. And eventually it has the metadata of this has been extracted using a DLL called qt.dll that will actually read the corresponding query information, translates it, and utilizes the connection server to connect back the underlying database system to connect it. And once it's connected, data produced data will then send back to the web intelligence processing server, which creates an EPF page. Then it sends back to the web application server, from the web application server to the web server, to the end user. Clear? Here the CMS life cycle is just limited into the initial request, guys, because it's an on-demand. It doesn't require to manage the status of it. Look at this. This is the whole line. Web server, web application server, CMS, again web application server, web intelligence processing server, input FRS to pick up this corresponding information. Using the qt.dll, it extracts a query and a query content, translates it, connects back to the RDBMS system, data sent back to the web intelligence processing server. From here again, communicate back to the web application server with the created page. Web application server, web server is a front-end end user. Again here, from here it will present back to the BI Launchpad end user. Connection server metrics. We have connection server has busy server threads, number of server threads, number of CPUs, disk usage, process ID, RAM utilization, server enabled status, running state, use disk space. We'll see them in detail in the CMS going forward. Connectivity service metrics displays different kind of information for each network layer and database pair. Status of the driver, what database system it can connect to, available connections, number of pool connections that can be used, jobs, number of jobs that are being processed, and jobs, number of jobs that are being processing web tier deployment. Two-tier, we have seen two-tier and three-tier thing, right? Two-tier talks about from the rich client. Three-tier talks about it from the BI Launchpad. When you have a web application server. Let me go back here, log into the CMS once. Oops, audio lost. Disconnected back. Just take a look at the other ones, dashboard design server, dashboard services. You can see dashboard cache server. You can see the discussed properties, whatever we discussed there, you can find them. Log settings, cache size, there is a default set. It translates into, I think, to 2 gig something. Connection timeout 15 minutes. Cache timeout is 20 seconds, 20 minutes. Metrics. CPUs 6 and corresponding usage of the size, disk space, available disk space, host name, and it also tells you the connected processing servers, the dashboard design processing server which is connected to this cache server. This is a list of it. Currently open connections for this are 0. Object type Excel .query. It's an Excel share server in the background. It also gives us the processing time details for the last 500 minutes, 500 requests. Last 500 requests which is being utilized. Number of open connections, data transferred to the end users, and if we have any auditing metrics to be cached, all that information has been maintained here. Again, similarly, you have a processing server. You have the metrics. This metrics looks quite similar to whatever you have seen, pretty much as the standard. Number of open jobs which are yet to be processed is 0, and number of requests served 0. We have not done any dashboard processing yet, so the value is set to 0. Type of job, Excel share server, and eventually the maximum, minimum, and average processing time is for the last 500 requests. Number of child processes which is being utilized at this time is 3, which you can override by going into the properties. Properties here, it also showcases the number of pre-started children is 1. Okay, this basically it tells you the additional conditions. Ideal connection time amount is 15 minutes. Job timeout is 15 minutes. Single sign-on expiry is 86400 seconds. Good. It's 1 day. 24 hours is the time. Out time. Similarly, you have underneath the core service, you have You can also go to the connectivity services to look at this connection server 32 and 64 connection server. You have connection server. Its properties are a bit of standard. You have native connectivity service, trace lock settings, connection pool timeout 60 minutes. Remember the connection pool we talked about? When you connect to the RDBMS system, it creates a pool of connections. The default timeout is 60 minutes. If an object is inactivity for 60 minutes, it gets terminated. The connection timer interval is about 5 minutes. HTTP request chunking size is 64 kilobytes. It's like amount of data that it receives, sends it back. One chunk, 64 kilobytes. Data sources, if you like to activate and custom data sources, you can also activate them by creating an ODBC, OLEDB, or various other things. Defaultly, everything is active. It can support all these connections that you've installed based on the client system connectivity. It also talks about the single sign and other timeouts. It's pretty standard properties, rest of them. The metric side, this is basically what makes details stable is for us. What are the different data sources which have been used here, and is it able to connect to these different kind of data sources? Okay, we don't have a DVD driver installed on the system, hence this status is failed. ODBC, we have a native ODBC driver supported for all of these additional platforms: Infomax, MaxDB, MS Access, text files, etc. These are loaded means you can build in. Remember, while installing the tools, we have selected the options, types of data sources that are supported. So these things have been able to connect to the system. OLEDB connected. Oracle OCI direct connections is not supported. Sybase CTL is also not supported, which is not at this time is not configured to be listening on. You need to start it manually, because if you remember in CCM you start SIA, whole services get started. There are 18 different services, 17 or something. So all these services get started automatically, because by default every service available in the BOE platform, defaultly it is designed to start with SIA. So you can overwrite it by looking at this property. Of course, if specifically, no. If you do not, let's say you have not selected this option, you started SIA, this will not start automatically. Okay? If someone tries to access a connection, a universe, it will throw you an error. Yeah? This, you can pretty much disable it. Let us say your platform does not have any dashboard servers. Let's say your customer that you have, he has a dashboard license, but he is not really running any dashboards at all. You don't need this service. We can simply, there are two ways. You can disable it altogether, or alternatively come down here, by uncheck this property, it will not start it automatically. If there is a need for you to start it later on, you can go on to do it. It is not essential for every organization you must have a dashboards. They might have a license. The licensing is again, if you go down to the Edge series, BOE Edge series, you will get crystal reports, you will get dashboards, you will get everything of it with one single licensing key. So some folks may not require it. Basically, the organizational need doesn't tells them that there is the needs this. Yes, accordingly license is procured. If they have about, to the best of my knowledge, that I know about 6 to 7 is that I'm familiar with. Different licensing models. 6 to 7 is what I know of. But SAP is so customizable. You guys know it. It's pretty much like the licensing model is varies to various other factors. It's about enabling, you can install everything, but you can activate it with the corresponding licensing key. Okay? Okay. So far good, right? Connection servers, dashboard servers. This is the, I think it's typically the last type of server we are looking at. Explorer servers. We can launch the BOE Explorer from within the BI Launchpad. We can launch the Explorer application. We can also open and explore an information space directly from the BI Launchpad. As we talk about Explorer, the name itself suggests that the tool is designed to explore or exploit the data. It has a concept called information space. An information space, you may call it like a package. An information space can be created on an existing universe using Microsoft Excel spreadsheet or consuming an SAP HANA model, etc. It has different kind of other options. An information space allows you to create dimensions measures by referencing an existing data or an universe. Once you create an information space, you can schedule this information space to be applied or updated on a periodicity basis. The scheduling can again be done or can be done from BOE application system. When typically install BOE Explorer, it simply adds a couple of servers related to the Explorer system. A server called Explorer Master Server, Indexing Server, Search Server, and Exploration Server. Let us see what are these usabilities here. Okay, typically the search server is quite widely used. Explorer Master Server is responsible to manage all of these underlying services. Indexing Server provides and manages the indexing of information space, data, and metadata. Like I stated, an indexing service is simply, as we talk about indexing in Windows system, when you are searching for a Windows of a specific document, it tells that this particular folder is not indexed. You want me to add it to an index, which is basically it sorts. In typical database terminology, indexing is nothing but sorting and rearranging it. While doing so, it also picks up its header and stores this information into a file. When you're trying to specifically search for the same information going later on, it looks for this file for a cross information and identifies this cross information. Eventually, you can directly locate this element that you're looking for in a faster fashion. Similarly, you have Explorer Search Server. Indexing idea is to read this content and create an index page. That ends the story. A search server, this responsibility is that when you are searching for a specific document or an information, or in this context, it can be even an element that is being used within the data set. It looks back the created index page, picks up the corresponding information and navigates it to the corresponding, or goes back, whatever is associated with it, picks it up from there. Exploration Server provides and manages the information space exploration and analysis capabilities, including search on data, filtering, and aggregation. Exploration server is responsible to allow you to create different kind of data exploration mechanisms for your data analysis. This includes filtering on the data, searching on the data, filtering on the data, or eventually different type of aggregations that you can create. It also allows you to showcase the data in different kind of numerous permutations and combinations of visualizations. Into charts, different kind of charts, into bar charts, column charts, line charts, pies, whatnot, different kind of charts, along with the different varieties of tables or tabularization of data that can procure. This also allows you to perform all of these activities in it. Okay, how it goes. Steps to the interaction of a platform components when we typically log into the BOE platform. How it goes. Let's take a look into the chart here. This Explorer web client is part of your BI Launchpad. Depending on your authentication, it will come in. Once you log in, web server, web application server communicates back to this, and eventually CMS communicates to the database system to authenticate or validate the authentication of this end user. Is he valid? Authenticated? Can he be able to do something here? All that information has been checked against it. Once this guy is successfully been authenticated, web application server will initiate a web Explorer master server. That means Explorer master server will also host the indexing service, search service, eventually Explorer service. All of these services are managed by the master server. Depends on activity that you want to perform by logging to. Yes. It is similar to the APIs we talked about. Adaptive processing server is one component. Internally, depends on the type of object or which is in context, it picks up the corresponding service to run this application. Do you guys know what is Explorer before? Heard of this terminology? Or do you guys use it as part of your application platform? I think you need to use it once. Each of the services that we discussed so far, you have to create at least use them at least once to make sure you guys are actually understand the process. Theoretically, you know, but practicality, once you execute it, it makes much better understanding. Okay, so that's the backtracking of BOE platform. When we talk about a service which is in context, we also need to understand how the application functions. Of course, this workflow will give you some brief idea how it goes on, but the actual functionality, it's once we use it just at least once, it makes us a bit more easier to backtrack what's happening in the background, where exactly the service is coming in picture, etc. Like I've been talking about, it has an information space. Our information space can be created on top of an Excel spreadsheet, or data that you extract from an universe, or data that you pick up from SAP HANA information model. An information model here, information space comprises, let's say this is an information space. You may call it as similar to a universe that you might want to construct it. It's for you guys. Okay. The whole idea is that here it contains dimension objects. You may contain three, etc. This is your source, let us say. You can pick up all of this information that you require to have into construct a new info space. So what happens here is that once you construct this information space, we can use this information space to schedule it, to index it. When you do an index, what it does is it picks up all the data available in this. whatever is the possible data that is possible on this sources, picks up all the data, complete data, and it creates an index on it, picks up all, it also creates various permutations and combinations of information. At the element level, it creates this information. Likewise, you can create numerous information spaces based on the source of the data and what kind of data that you want to assess it going forward. These created information spaces will then be used to schedule to run on a periodic basis. This again, an APS will come in picture, adaptive job server, which he internally calls the corresponding processing server to perform this. Eventually, once this information is been solicited or presented here, then you can see, you can create, like I stated, you can create numerous services of this. All of these things will be presented to you on the home page of your BOE Explorer. The moment you launch the BOE Explorer, on the first page you can see on the home side of it, you can see the list of Explorer services that are available, list of information spaces that are created for you. Okay, so eventually from there you can click on it, it will allows you to, it opens it up, you can start playing with it. You can do a navigation, you can do whatever is appropriate and possible for you guys. Explorer Set Server provides index reference to the index in use of the Explorer Master Server. Explorer Master Server uses a reference counter to manage the sources. Explorer Set Server sends a request to the CMS to obtain the list of information spaces available to the user. You can also, once you create these information spaces, you can designate, you can authenticate the end user on what particular information space you want to provide access to. Eventually, the CMS checks the CMS system database to identify the information space available to the end user. CMS communicates back to the Explorer Set Server that this guy can only be able to access this. He cannot have, whatever is possible, it will respond back to the system and showcases the information in this area. Explorer Set Server sends a list of information spaces to the Web Application Server. Web Application Server sends a list of information spaces to the web server to the BOE Explorer web client, where the list of information spaces is displayed on the home tab. Like I stated, on the home page, you can see the list of available information spaces that the user who logged into the platform is authorized to access and has an access to. Clear, folks? Web client, web server, web application server. In the meantime, communicates back, web application Explorer Set Server will communicate back to the CMS, identify the information, what is authenticated, what are the areas that he can start picking up the information to, communicate back to the Explorer Master Server, tells that okay, these are the things that he has access to, and the same, once it has been authenticated from the CMS, from the Explorer Set Servers, talks to the Web Application Server and Web Application Server to Web Server to present the list of authenticated services, information spaces that a user who logged into the platform can access. This process flow explains you how you can create an information space. I think you can, once you, later on you can practice it, it's again available in the material. You can also create an information space on your own by logging into the BI Launchpad. Here the cycle, a process flow of this will typically talks about this. Request from the Explorer Web Application Server, Explorer Master Server, CMS authentication. It picks up information from the corresponding universe or whatever the object that is associated into the platform from the input FRS, create a model on top of it. Created model will be saved into the CMS and will also be notified by the Explorer Master Server it has been created. Communicate back to the Web Application Server. Explorer Master Server sends the completion request. Web Application Server will be notified, Web Application Server to Web Server and to the end user. You can create one simple sample using an existing universe. You can create one. a simple information space, and you can pretty much be able to navigate from there. Okay, you have the steps detailed included in here. This is based on an Excel spreadsheet, and this is based on a Microsoft a universe, an existing universe. Cycle is going to be the same, just the same. Indexing an information space, if it is based on Excel or even on universe, is going to be the same. Once you create an information space which is going to be available on your home page, you can select this information space, right click and say index. Indexing in the background communicates back to the system. Take a look at this. It talks about the web server, web application server, master server, looks for the CMS authentication and whether he can do this or not. It communicates back to the input FRS to pick up the corresponding metadata. Eventually, that communication sends back to the indexing service. Indexing service internally communicates back to the connection server to pick up the underlying data. Underlying data communicates back, connection server communicates to the RDBMS system. Pick up the data. Picked up data will send back to the Explorer indexing service. Explorer indexing service will use, because this requested data will need to be translated into system. Information space also contains the data. The data requires a storage, which is an Explorer storage, which is separate from the FRS, where all the data extracted from here will be dumped into the Explorer server. On top of it, the indexing service creates it. Created index pages are preserved with indexing server. This will notify the completion of the service to the master server. Master server will send this request back to the application server, web server. If you notice this whole idea, without we might not realizing it, the moment it calls a universe, universe internally calls a connection server. Right? A connection server again internally backdroply connect to the relational database management system. It does a request response processing and procures the data. Procured data will then send back to the Explorer storage. And once it is stored in the Explorer storage, you will start creating an index on it. Created index will be preserved with the Explorer index server, which then used as a reference to a master server gets notified about this information. Will send this information back to the end user client. Clear? This tells you how this is basically, if you like to view a file which is based on an Excel spreadsheet. What happens here? Web client, web server, web application server, connecting back to the exploration server based on what kind of data that is in connection with. Communicates back. This is an iteration based on what kind of data that you want to perform. Every single action that must be served by the Explorer master server. Explorer master server is a master process and the rest of them are its child process. Everything is controlled within the Explorer master server itself, which communicates back to the different other areas, and eventually based on the index created and all that, it will pick up the data from the Explorer storage and present it to the end user web application server and to the web server to the Explorer web client. This is an iterative process. It's a recursively iterative process. Based on what element that you want to look at it, how would you like to look at it? Your searching service is also part of your Explorer master service. Clear? Okay, so let's go back to this CMS and showcase these services on the Explorer services. Oops. This one seems to have Explorer installed in it. Just a second. This is the end user web application, BI Launchpad. No, it doesn't have Explorer installed inside. Maybe the license key is an issue here. Let me check on that. Probably by on Monday, if I could get different keys, I'll showcase that to you. But basically, yeah, but I don't see any Explorer server. Then only I realize that this application is not installed. Usually, if there is one installed, it will be the last service here. Here you can find it here. Okay, we'll talk about this on Monday in detail. We'll be navigating it here on setting up the preferences, etc. All right. Say again? We'll take a break now. Yeah. Folks on the phone, we'll be heading for a break now, and we'll be back in about 15 minutes now. Okay, guys, back in about 15 minutes. Thank you. All right. Let's discuss this about the event service. Okay, the event, the name itself defines, it's a triggering point, right? Right. Events are objects that represent occurrences in the system. Depending on the type of the event, events can be used for a variety of purposes. Events in the business objects platform are typically being used to work with scheduling an object, usually to scheduling an object. Basically, you might want to create, you do not want, although you schedule the report to run at 3 a.m., let's say, but you only, at the same time, you want to make sure your other regular data load completes, which is from an ETL perspective. Let us say an ETL job, the moment it completes processing the entire data, only then you want to run the report. Although it is expected to complete it by 2:30 a.m., it may not be finishing by the time for various reasons. Okay, you want to make sure you're scheduling a refreshing of the data which can be controlled based on an event linked. Event server's responsibility is to manage the events. Predominantly, they act as scheduling dependencies which trigger specific actions once a scheduled job runs. This typically comes in picture when you start working with jobs that you schedule to run over a period of time. And eventually you can create this variety of events which can utilize to balance or making sure that it will not allow the job to start until the pre-decided or predefined existing event gets triggered. The triggered alert notifications. Alert notifications again talks about, this is basically a system-based alerts, such as a specific service is not really working in an appropriate manner, etc. They allow the system administrators to monitor the health of the system. Events are used to trigger the alerts. Different types of events exist here, guys. File events. When you define a file-based event, you specify a file name that the event server should monitor for a particular file. When the file appears, the event server triggers the event. For instance, you might want to make some reports dependent upon the regular file output of other programs or scripts. File events are typically stored in the system events folder. Like we've been talking about, you have an ETL job which its responsibility is to pick up the data from underlying data warehouse or different sources of data and move the data into the data warehouse system. You have a report which runs on top of the data stored into the data warehouse. If the ETL job fails to complete on time, okay, even if you run the report, it may not produce any data. The report is not completed, it will not produce any data. Basically, you might just going to have probably a blank report. In such case, if the report is dependent on the data that is generated by an ETL structure, and you want to make a dependability of your BOE reporting, a report to be refreshed subsequent to a file generated by previous ETL application platform into a specific location. Eventually what happens here is that you create a file-based event from the events application into the BOE platform. Here you could also go on to specify or create an event which starts looking for a file in a defined folder. Until the time that specific event or the file gets available in the specified folder, your report will not start to process. The scheduling is still be waiting for the specified event to be triggered. Similarly, you have schedule events. When you define a schedule-based event, you can select an object whose existing recurrence schedule will serve as a trigger for the event. It means you want an existing report to be completed before you start a new report. This particular report to be waiting. This way, schedule-based events allow you to set up contingencies or conditions between scheduled objects. You might have two different reports. Maybe you might want to build a dependency that report number 1 should be completed first, report number 2 should be following next. You have scheduled these two reports at, let's say 1 AM is one, 2 AM is other one. Let us say the 1 AM report which starts at 1 AM but goes on to refresh until 2:15 AM. Although scheduled second report which is supposed to start at 2 AM, which will not start until the time it gets a notification for the report number 1 gets completed. It's like building a dependency between the multiple or scheduled reports, scheduled programs basically, objects. Custom events. When you create a custom event, you can also create shortcuts for triggering an event manually. You can, let's say you create a custom event, it can be a file-based event. You want to create the file manually into the specified location so that it gets triggered. It's a manual automation. They are part of the, they're stored in the custom events folder, guys. These are the variety of events that exist in the BOE platform, and you have an event server which is designed to manage these events. Event server is the name of the service. It's again the core service. It monitors for the file events in a file repository server. Typically files look for a file in the FRS. Monitors the systems for event, which can act as a trigger for running a report. When you set up an event trigger, event server monitors the condition and notifies the CMS that an event has been completed. It's basically just been occurred. CMS can then start any jobs that are set to run on top of that particular event. Clear? Events all the time looks for a file, typically in terms of the FRS. It can be scheduled events, typically being done on top of objects that have been scheduled, created, which are part of your FRS. You can also create file-based events, which you still host them into the FRS, input FRS location. Start looking for the specific file to be available in there and start creating the or scheduling the report. Typically used for system monitoring as well as report scheduling. Event server properties, it has cleanup interval, specifies how often cleanup utility runs in minutes. Default value is 20 minutes. Event poll interval, how often the server polls for a file that triggers an event in seconds. Default value is 10 seconds. A range of allowed values 1 to 1200 seconds. There is a polling service in the background which will start looking for a file's existency. If you create a file-based event to be available in a specified designated directory, okay, it is expected to be available by 2 a.m. in this previous example. If it may not be available by 2 a.m., it will start polling the system for every 10 seconds and see if it is available. Has it come available or not? Is it been available or not? It will start polling the folder to locate the specific file. You have an event server matrix. One second, guys. It also has matrix list of monitored files. It gives you the list of files which have been monitored in the directory, or what are the list of files that the events have started looking for monitoring. The column also displays the name and path of the file. The last notified time displays the latest timestamp of when the server did a poll and found that file existence. As we talked about in the previous two properties, it specifies the frequency of the polling time, how often it is to look for. This here, this monitored files will also give you these last notified time. The moment it finds a file, it will actually update the system that this is a file has been found in this area. Monitored files, the total number of files that are being monitored by the event server. To do this, guys, let me take you through the CMS, the CMC here. Give me a second. In the CMC, you have an application called Events. You have different types of events exist: crystal report based events, custom events, monitoring events, and system events. It's the categories of the events. Here you can create a variety of events here, guys. You can create an event which is part of create this. This allows you to create a new event. You can create a type of event, file event or scheduled event. If it's a file event, you can specify a name, a location. This should be the path and file name of the server. Path and the file name with an extension. Eventually this will start monitoring this file's existency in the designated folder. Similarly, you can also have a custom events. You can also create a custom event which can be manually been triggered. The moment you can create an event here, you can select this created event. Let us say I have an event created. You can right click and say you can trigger the event manually by going into the system. Clicking on this button will trigger the event. Yeah. Eventually, all these triggers that we constructed here are being managed by server type called event servers, which is part of core services. You can see its properties. Event poll interval seconds is default is about 10 seconds. Allowed values is 1 to 1200, which is maximum is 20 minutes of interval cycle that you can specify. And cleanup interval is 20 minutes is the default setting. Similarly, you have metrics. This will give you the list of metrics that are being utilized. If it is being started looking for a file monitoring, it will showcase the file's location correspondingly with the table, etc. These above statistics are pretty standard, but these are specific to this. Okay, so in order for us to perform this action, events pretty much can be done here, which can be used back with the while scheduling a component. When you schedule a report, you can, whatever the events that you created from the events application are available for the end user. They can use these events to be part of, included as part of their scheduling mechanism. Clear? Folks? This concludes the servers details here, guys. Any questions so far? No? Okay. This would be the topic. Discuss on the how would you like to troubleshoot the BI platform? What are the different areas, different things that we need to take into consideration when you need to troubleshoot the BI platform? A strategic troubleshooting method is basically a typical standard strategic way of looking at your BOE platform troubleshooting scenarios. We need to first look at these things in a proper order, guys. Are we able to log into the CMS at first? Are we able to log into the CMS at first? That's the primary thing we need to look at it. In terms of troubleshooting, can be of various types. It kind of, it is a strategical step that is associated with it. These are all the things that you have various scenarios to be addressed. Could you just excuse me for a second? Guys, you can pretty much take up a strategic troubleshooting method, which is typically to identify a function or a process which is not operating properly. It can be, if we already know, if you're familiar with the application services, typically as we have discussed so far, the events, based on the process flow that we have seen on a different services that are in context, we should directly be able to go down and start doing a troubleshooting in there. But apparently, that is not the case. Other things that you need to check is basically, are you able to open the CMS or even the BI Launchpad? Are you able to view the BI Launchpad or CMS? Are you able to log into the CMS? Can we navigate through the folders and see a listing of the reports in BI Launchpad? Maybe some cases what happens here is that, the step number 4 will typically tells you that if there is any reconciliation process problem between your BI system, which is your file repository service, as well as your CMS, if an instance P, there is a difficulty or problem that exists. And entries that are found in the CMS, we cannot find the corresponding files. Okay, it lists you the folder, a report, but you cannot be able to access it. It basically, then you know where to look for, right? In this case, you will typically go down to look at the RDT, a report, repository diagnostic tool. You run it with the corresponding parameters to do a synchronization and look for what are the possible problem areas that you have. Okay, are you able to successfully schedule a report? If a scheduling is not properly being done, it's a problem with the adaptive job server. Job server is not really functioning properly in order for you to schedule this document. It may be you are unable to look at the events. Although you created the events are not available for you while scheduling a document. In such a case, it tells you that the probable scenario here is that event server might be down, or it might have some difficulties in discharging these events that you have created or constructed for. Are you able to view successful instances of any report or web intelligence document using all possible view types? This tells you created the thing and you wanted to you schedule a report to be publish this data into a local BI system default flavor such as web intelligence document, crystal report instance, or eventually you might even have created this report to be output into Microsoft Excel spreadsheet or CSV files or anything else. Are you able to view them in a successful manner? Are you able to view objects on demand using all possible view types? Basically, viewing them on demand is like instant. It's not a scheduling object. You want to edit a report, you want to view a report that is available in the BOE system and repository. Can you be able to do that? That's something you'll typically start looking at various of these activities. Step number 2 will illustrate enumerating the possible sources of error. Identify the process flow that details which servers are involved in the function or process that is not operating. Step number 1 explains you the possible varieties of errors that you may get. These are the possible varieties of different types of errors that you might get. Step number 2 tells you what is the process flow which is in connection. As we have seen, a web intelligence document has 2 different process flows. A scheduled document has 1 process flow, or I know already on-demand report has another process flow. But eventually you have third type of process flow which tells you that a cache server based process flow. So you are viewing an existing document. So you need to look at the action first. Based on the action, you will have to enumerate what are the possible process flow that comes in picture. Go back to the system and start looking at that process flow direction. Right? So once you have determined the function that isn't operating properly, find the associated process flow with that function. Use the process flows to determine which server or component which is involved in it. The troubleshooting is now broken into a component level. At a higher level, it looks too big. Based on the identification of the process flow, it has been streamlined and curtailed to a shortcut path. Narrow down the possible sources of error and analyze. Follow the process flow to the server where the point of failure occurs. You may be able to temporarily rule out the servers that precede the point of failure. Devise and execute tests to verify which servers are functioning properly. This is something that you need to take a look by doing various activities. Let us say you have a concern. You may think that adaptive job server may not be functioning properly. Try to schedule a document and see it. If that's not functioning, there is a possible cause with the adaptive job server is malfunctioning. And what kind of problem that it might give you on this? It can be probably service is down or disabled. This has a solution is to restart the service, wait for some time, clean up the resources, restart the service and try it again. Let's say you're trying to view a document which is in web intelligence application system. It throws you an error, document cannot be opened, which is actually an error generated by web intelligence processing server, which is unable to open corresponding document from the input of, it can be an output or input FRS. That means a communication problem between these two. Go back and take a look at the web intelligence application. Is it working properly or not? If it is working properly, then this potential issue is on the FRS, input or output file FRSs may be done. Are they down? No, if they're working fine. Look at its metrics. It tells you the usage. Go back to its properties. It tells you what is the maximum allowed number. Has it reached the maximum allowed number to be utilized? All these things allows you to break this entire troubleshooting process to the minimum. Clear? Sync? Test another process flow that also uses the suspected service to eliminate possible sources of errors. Target your efforts on the most likely sources of errors. Okay, some of them are, these are partial list of these errors, exercises that we may have to employ. Examine the SIA in the CCM. Is the SIA running? SIA is down, meaning probably its communication among the services being controlled, disconnected from that itself. CMC, are all the settings for the service are correct? Which may talk about various types of settings that we have seen. Which also has a service commands, JVM related properties, logging directories, etc., etc. Are they running fine? The Windows file directory structure appears changed. The files are renamed moved or missing, especially in the FRS side. ODBC data source connection to ensure it connects to the CMS system, database system. You can also need to take a look at the CMS level properties. It has a communication which is properly been maintained and managed between the systems. I've typically been able to refresh the crystal reports or one of the reporting system. I refresh a web intelligence document within CMC or BI Launchpad, or you can use an application event log by going into the logging directory. So locate the specific service which is in connection. We also have trace log files that have been generated into the system. Typically, you can use these files to identify the log scenarios, or rationale or reasons for the logs, or reasons for the service is not performing. Same in the logging directory. You can also file the event files there, event traces. Okay, couple of things that allows us to look at these troubleshooting and monitoring aspects of it. You can use alerts, watches, probes, metrics that typically gives us all of this information. And eventually, you can also define a monitoring application as we talked about it. Using the monitoring application, you can set up a monitoring, you can create a dashboard, monitoring dashboard, in which you can assign the corresponding job service that you want to manage, corresponding system services that you want to manage it. You can set up a threshold for each of the service utilization, which internally triggers an alerts, which can send back to the user's BI inbox, which is part of your BI Launchpad. From there, you can start looking at this information and start doing a troubleshooting process. Widely used options are alerts. Alert is nothing but a notification generated by the monitoring application. When a user-defined threshold value set for different metrics applied to a watch is breached. Monitoring applications contains watches. These watches are created based on a service level, which also includes a threshold. Minimum level, maximum level, or the ranges of levels. Once they've been appropriately associated, if the event has been clocked more time or less time, it can create an alert for you. The created alerts sends a message, and this created message will be available in your BI Launchpad. On the home page, on your right hand side, bottom corner, you can see alert notifications. Something like this, guys. These are all the crystal reports, event services, etc. These are the alerts that have been generated by your monitoring application. These are all alerts. These alerts are generated by monitoring application. Monitoring application, you can create different kind of watches. One second. Sorry, you said, or what were we saying? Overall health. Consolidated health watch is failed. There are probably one of the service, let us say the core services, which has defined a threshold inside. The threshold might have been breached. Look at them. The CMS, take a look at this. CMS has, click on this, it will showcase the corresponding watches defined on it. There is a watch rule that is set forth for it. This tells you there is a danger rule. Okay, the CMS communication, it breaches a certain number of seconds. If it is unable to communicate between CMS system databases, communication does not happen and defines interval range. It will trigger an event that it is unable to communicate with the specified time, it will be marked the event as failed. Sorry? You can come down here to create a watch list. Go down to the watches here, you can create various watches based, create a probe. A probe can be defined on top of a service. Let us say these are all the various things that I have. Okay, let us say I want to create a CMS ping is one probe. My ping time, when I do a ping time between my source CMS system, it should be an appropriately and a lesser number of seconds. These rules does not indicate it is actually being fair. This does not, okay, I understand what you're saying. You're saying this overall health is a fail. That means your assumption is that the service is fair. No, it is not service is fair.
It's not like that. How to make it successful?
Okay, to make it successful is basically, okay, there are two things about it. If you want to make this successful, you need to analyze what is the root cause first. Okay, let us say the root cause on this. Okay, if I look at the crystal report related services inside, I have crystal report processing server. At first, I need to understand what is the metric which is causing this reason. Okay, the reason for this is basically, okay, I have caution rule is set for threshold is greater than 5. This is my rule that I have set forth. Okay, it is basically request failure rate. Crystal report processing server dot request failure rate. The dangerous threshold that I have set forth here is to greater than 5. 1 second. Let us say it is communicating to the system, the communication between the system, it is taking more than 5 seconds to respond. That is the reason I have set it as a dangerous test. In order for me to troubleshoot it more, the next thing that I need to go back to is go down to my service. Navigate into the crystal server. Yes. I have crystal reports 2011 processing server. Look at its properties. Maximum number of restarted children is this. Idle connection timeout. One second. Go back to the metrics and see what is causing the issue. Nothing has been processed here. It's still showing a communication here. 1 second. Second. One second. This threshold, if you notice, it has been set forth for 0. That means this health status, how it determines. Give me a second. This is it doesn't have any communication being done here. So basically, the whole idea for this to tell you is that if you can set forth a threshold specifically for a watch. You can create multiple watches which may contain different kind of metrics that are being utilized. Let me showcase it to you by creating a metric, how we can create a probe, okay? You can go down to the metrics. This is for the CMS system, okay, number of defined crystal reports. This metric, let us say there are 22 is the default value. I can also change this value, guys, basically. Give me a second. I'm just trying to. Okay. Number of defined reports. That moment it reaches more than 22 reports to be processed, it will trigger alert. But it is not well. If I can also navigate this to change here. Just 1 second. Sorry, this is the metric level, right? I cannot change it here. I can create a probe on it. Apologize. By create crystal report service processing server, you can create an execution time based probe. If the execution time for this takes more than a specified amount of time, just a second. Okay, this is number of crystal reports. Let's say. Just a second, I might have some syntax errors here. The whole idea for it is basically you can create a consolidated matrix at first. You can specify its threshold limits, and eventually this threshold or a parameter, what happens here is that it only allows you to create on the numbers which are available in each service property. Let us say in a crystal report system that you have number of jobs that you can process. Let us say on the property side we have set 10. The moment it reaches 10, you want it to be create an alert for you. That's something you can create it by coming into a metric, and a created metric then we consolidate it into a watch. You can create a watch. A watch can contain substantiated metrics inside. The moment these are customly created alert messages that it is this threshold is actually reaching at this time. Is it breaching or is it close to reach, etc. So correspondingly, if there is an event triggered in this, as you noticed in the overall health status, it is showcasing a trail that predefined set parameters are not satisfying, or basically it is not satisfying the condition to be successful. Hence they've been marked as failure. That's basically a trigger point for us. That trigger point, we'll have to look at it, what kind of parameter that has been set forth in connection. Go down to the associated service property, go down to the service and look at its properties, and reconfigure its property with a specified value. I'm just trying to figure out how I can showcase the one sample value here. Give me a second. Let us say you have this connection server. One of these connection server 32 has been disabled. You can see the status here on this. Sorry? Yeah, connection server 32, and no, this connection server 32 is disabled. 64 is also disabled. Connection server, this is also disabled. This is also disabled. Adaptive processing server, it has a status set as failed. So you go down to the watch list and look for this adaptive processing server. In the core services, maybe that might just be the case. Adaptive job server, this is job server health. I need to look at the processing server. Let me look at this SAP ECC watch. Okay, adaptive processing server, it has been disabled. That's when this is like, the status tells us is this not active. Okay, eventually guys, click on this edit button to edit this. This is what I was actually trying to look at it. We can specify a caution rule. This rule that it has been specified that, okay, let's look at the danger rule, which is marked as danger or fail, right? Okay, there is a CMS system, a CMS ping time. Okay, if this value equals to 0, then it is dangerous. Similarly, you have an adaptive processing server. This adaptive processing server corresponding metric, which is typically a ping time. The ping time for this is 0, then it causes an alert. If you notice this in this context, this is basically it's been disabled. Hence, its ping time is, it doesn't really ping it up basically, the whole idea of this. Hence, it creates a danger rule. This is basically, we can set the rules. When you want to make it as a normal on a cautious note, what is a normal, what is a cautious note, what is a dangerous rule? Danger rule defines it as, marks it as a fail. In a watch list, if one of the service fails, watch list combines several services inside. One of the service fails, the entire watch list, it marks it as fail. Similarly, you can also go down to this. You can add additional services that are part of it. Let us say you want to pick up this health state or enable state. If this enable state equals to 0, okay, if this enable state equals to 0, I still want to make it as, mark it as fail. Clear on this? Now, the whole idea for this monitoring application is to enable you to create watches. A watch comprises several services. A watch is nothing but a job, guys, in the background. You have service 1. You have service 2. Eventually, collaboratively on this variety of services, cumulatively you want to create a watch. A watch is nothing but looking at the status of the service. A watch can be created based on a variety of the metrics of a specifiedly selected service. If I look at adaptive job server, it has server enabled status. 1 equal to enable, 0 equal to disable. If I set a value of danger if this value is set to 0. This value is set to 0, this can happen by service by itself when you have, as I told you a while ago before, when you have many requests that are coming into the system which cannot accommodate it, it may go into disabled state. Or alternatively, when it reaches the threshold that you set forth for number of report requests it requires to be processed, and there is, after some time, the threshold reaches, it cannot accommodate new services, it goes into the disabled mode. Or eventually, when you want to restart the service, you may disable its state to restart the service. Right? This can happen by programmatically or manually. Whenever this status tells you the value of 0, it marks this event as failed. The moment the service fails, it might mark the entire watch as a fail, which eventually produces a trigger. That trigger will be viewed, will be sent back to the designatories, which is typically administrators. You can look at from the navigation panel. Coming down to here and look at the watch. What is the reason for this failure? You come down and look at this is the reason for failure for this enabled state. This tells you that, okay, this has occurred because the state is value is set to 0. Then immediate next you go back to your BOE system, look for the service, is it really disabled? You typically find it gets disabled. And then you will start looking at a reason. Is it you have disabled manually because you are planning to restart the service? Or the system by itself got disabled because it cannot accommodate new requests? Then the moment you know the answer for this is like system cannot accommodate the new request, you go down to the service, look at its properties, you will change this number of allowed processing jobs. Let us say previous value is 10, you want to increase it by another 10, 20. After that you need to reboot it. Service must be rebooted. But this whole idea of this status or this particular probe and its status tells you is that with the defined condition it can match. If this cannot match, it has a cautious rule or even into the dangerous rule. If it falls into one of this category, if it falls into the dangerous rule, it marks the entire watch or the set of jobs, set of services that are part of this job will be stated as failure. Because it's a completely like package. Did you get this now?
What we do is, let us change the danger value for connection server 32. Let's see how it reflects. This is the fourth one.
1 second.
Previous one was.
1 second. No, you need to create a new one.
Notice the danger value for
Give me a second. Danger rule, we do not have one for connection server. If server enabled status,
earlier it was showing us it is not in disabled state. Now we will try to enable it.
okay. This value equals to 0.
Can you click on that drop down?
This one?
Adjust it to the greater. Yeah.
You can, oh, okay. You can see equal to, this equal to 0. If this value equals to 0, we want to make it as dangerous alert. Okay, if this value equals to 1, is that what you want to say? Equal to 1, then you want to make sure this gets triggered. It's SAP ECC.connection server. Say again? Sure. Part of this is actually being covered into the subsequent steps, which is from Monday, Tuesday, and Wednesday going forward. One of the days in that, we'll typically look into it. This eventually it creates a trigger. One second. This value is set to what? 1. I'll go back to the services now. It is the ECC event, right? It's the ECC watch. One second. The dashboard. This connection server is actually disabled. SAP ECC connection server 32. So we need to restart it. We need to enable it. Notes ECC. Oops, everything is stopped. Connection server. Maybe somebody may be testing some stuff. This may be the case. The port might have been blocked out. No, this is a separate SA, right? Okay, it may be the reason. I know. Because we're sharing the same TMS, running in 2 different SAs, it might have created a conflict. Go back to the monitoring server now. One second. Still starting, I guess. So service now latched onto something else. Okay, service is still starting, or it's Still initializing.
It is in disabled state. That could be a reason.
That's the reason it is unable to open the monitoring application. It takes a little time before it gets started.
No, what I mean to say is, I think we need to enable it also.
No. Let's see the give it some time.
Because which even the process side is not there.
Yes. But actually, I'm going to have a topic on it separately on monitoring applications, which is a couple of days from now. It's good. Look at this connectivity now. It's okay. It's okay, is it? SAP test is disabled. SAP test is disabled. ECC still disabled. Huh? But we see it enabled here, right? Connection server is enabled here. The status showcases it as okay, corresponding probe is disabled. Hang on a second. Its watch name is this.
No, here we changed it, right? The probe,
We have changed it, but it doesn't seem to have affected here. That is for the SAP ECC, right? 1 second. Okay. Yeah, it's showcasing it as an error now. Previously it's disabled. Previously it's disabled. Previously, if you remember, it's all grayed out. It's grayed out. But this value is failed now. 1 second. Why it is been failed? Let's take a look. Let's edit this probe. Edit this watch list. Connection server. Enable state equals to 1. Danger. We have set the if it is 1, we wanted to make it as a danger.
So one is nothing but
Enabled.
enable.
Yeah. We have set this as if this value equals to 1, then the danger. Look at the danger rule. We are setting it for danger, right? This value.
We'll put it, take it back to 0.
Let's see. Okay. Test 1 second. We have for ECC, right? Just now. Okay, I think that pro, it's working fine, I believe. So is it disappeared?
Let's see the dashboard with guard disable.
One second. Connectivity. One second. Okay, let me just refresh this entire application. This watch, okay. Go to watch details. This is my watch rule. Running state equals to 3. Handle properties.
See, now the value is 3.
The watch status is disabled here. It's not about the, if you notice this watch itself is disabled. Okay, let me go back to the watch list and look for okay, there is ECC, right? This one. Okay, this one, enable watch. Okay, this one, connection server, enable watch. Now it has individual rules that are set forth. By looking at it, edit it.
I think by default it will be in disabled state.
Not necessarily. I think there is some mess up has happened.
Go back to dashboard and check.
Dashboard, now it gets enabled. The status also states it as okay. So look at this parameters now. It has been, overall, it still has another service which is part of it has been disabled. Test. So it's also part of the service, this particular watch list. This typically making this entire watch disabled. Failed status. Eventually is applying into a failed status here. But if I want to understand it detailedly, I can specifically go down to the service and look at the rule of watch. Okay, servers.running status equals to 3. It's basically, I think it's fine. Cautious thread, I just can't remember exactly because each of the service has a specific number. I'll show that to you on this. I'll show that to you as part of the monitoring application detail. But these numbers will vary based on the service to service, I guess. 1, 2, 3. I think 0, 1, 2, 3, I believe. Enable, disable, and various other statuses. I'll check that up and get back to you on that. We'll discuss them in full length on that. But by default, if any of these created watch tool gets failed, then the whole idea of this job status will be marked as a fail. If I want to make this enabled here again, let's see this. This is my watch, isn't it? What is this? Connection server SAP test. This one. If I enable it and go back to the system now on the dashboard side, one second.
Stop the test.
Right. So because of that, it's getting into disabled state. If it is able to ping, and if it's disabled by the watch, the status will again gets changed from fail to something else. Clear on this? We will discuss more about this in the monitoring application subsequently as we go into the next week sessions. But basically the whole idea is this will tell us what is the troubleshooting mechanism with that we can adopt and get into it. I'll create some 1 or 2 sample scenarios for you. We'll discuss them in the visualization. This monitoring application is a bit confusing because so many things are interlinked with it. Right. Right. It's going to be making much more sense. I'm going to remove that node anyway. Let me remove this node. Start. It clears a lot of air now. Sorry? Yeah. You have, okay, connectivity services watch has been failed. Let us see why it is being failed. These are in a OK stage. Connectivity services. This one, it's overall healthy, is showing it as okay, take a look at this. It's showing okay here. The overall health status is showing okay here. It is showing as failed here. I think let's try now. Maybe it's a synchronization problem. And maybe a little time it takes to sync it back. I think the overall culprit here is not this, but the other node that we constructed. Because services there have been stopped, it is referencing as part of the monitoring application, telling us it's been disabled state. Okay, this is one of the various ways that you can apply, adopt to troubleshoot the BOE platform. We'll discuss separately on this probably at the couple of days in the next week. One of the days in the next week. Clear? Yeah, there are watches that you can create it, probes that you can set forth it. What I'll do is I'll create some scenarios for you probably by Monday or Tuesday. One of the time we'll dedicate some time for this in a real world scenario. Let's say what if it is will apparently disable one of the service, will make the service trigger an event for you to an administrator. So administrator looks at it, how we can respond back to it. Otherwise you stop a service, a CMS ping out time, it is not running in a proper manner, how we can resolve that. So we'll create one or two scenarios for you. We'll discuss that in full length so that this clears the air for you. Yeah, apparently we'll see it on Monday or probably on Tuesday, whatever this time appropriate for us. This is all related to watch data itself. I think I'll discuss this again, once again, in complete length with you on that. Okay, we have seen this problem just now. Graphs show different times on the live and history modes. It may be a case that it might have different time zone based settings. It might have been an issue on the different service. If you're running in a clustered environment. If you notice this, we had one more node just now. That might have been a culprit to showcase the different information for us. Enable host metric option. Host metrics are not listed. The host metrics is something that comes from the monitoring application itself. You can create these metrics. These are all the list of available metrics for each of the service which is in context will be showcased for us. These are all the metrics. Remember this adaptive job server busy server threads is a property, if you remember. That property is available for us to monitor it here. Likewise, process ID, health state, if this value equals to 1 or 2, etc., how we can troubleshoot that. And eventually restart the, we can, if something, this particular information is not available for us, then we will typically go on to restart the adaptive processing server instance after making corresponding changes. It will verify for us basically. The graph, a trending graph that it showcases the utilization of the specific resource, which can be process threads, which can be number of users logged in, number of reports which are being processed. That will showcase at the live graph to be utilized. Graphs typically shows a different time zone. This is a time zone issue that we typically have to notice it. Right. That is all I have set forth for this today's session here. And when we meet up on Monday, we'll first discuss the monitoring application, possibly. If not, we'll talk about the security models. Then we will include the monitoring application with a couple of samples. Any questions here before we wrap for the day? Monitoring? Okay. Okay. You want to see services running, is it? You can see a service that starts with business objects. SAP. One second. No, it will see it in underneath the SAP, I guess. SAP business objects. ACC, SIN node. This internally controls the rest of the other services. Previously, in the older versions, you will need to see all the number of servers that you created will be created as service in the Windows. Service. Start, restart, disable, etc. The same thing that we see from the Windows system as well. Sorry, CDM. Yeah? See, this now it's changed back. The culprit was the this service which is associated with it. But we can create some sample scenarios. Not an issue. Any other questions? Guys on the phone, any other questions, guys? Before we have the session, any other questions here? Right, so assuming that you guys are clear with this, and I would like to wrap this session here today, and we'll see you again on Monday at 10:30 a.m. IST. Okay, that would start talking about some access levels, etc. Monday. Thank you guys, and have a wonderful weekend. See you on Monday. Take care. Bye-bye.